Hello? Okay. Hello, everyone. I'm Ionut-Viorel Gingu. I'm a blockchain security researcher at OpenZeppelin. I'm going to give just a short, very introductory talk about how to use AI to speed up your audit process, improve its quality, and make sure you have just a bit more time to focus on the complex flows that the AI can't handle. So AI has become quite capable. It has this internal multi-step thought process that can split like a complex task into sub-problems. It applies transformations on them. It retrieves relevant memory from the conversation you have with the AI. And then sometimes it also does error checking between the process that it made and what was expected by you. It also has a bigger context window, up to 400,000 tokens. Just a simple analogy for the context window, this is the amount of information that you can flash through the AI in one go. The AI is like this big mathematical function with a lot of parameters, so the more relevant information that you can fit within those 400,000 tokens, the better it's going to perform. And then there are also all these powerful wrapper IDEs such as Windsurf or Cursor that already ingest part of the code base as much as it fits and then add some heuristics whenever you interact with the AI, such as better web searching, summarizing information, aggregating it, and efficiently spending tokens. So this creates an opportunity to use it in your audit process just in very, very simple ways that anyone can do just to understand the code base better, and we'll see a couple more examples. So here I have just a simple example. I downloaded the Uniswap v4 code base and I asked a simple question. Can you just explain this code base to me, high level, and give me the key components? And in 30 seconds, it was able to tell me that it has a singleton design, it has the pool manager call contract, it has 5 key operations, there's this hook system inside that executes custom logic at all these lifecycle points. And then it told me the key libraries and supporting contracts. So with just more simple questions, you can dive deeper into each of these components and even go through a flow like from user interaction through all the contracts. Second really simple way is just understanding complicated code that, for example, this big block of assembly. This is again from Uniswap v4 core. Most significant bit function is giving you the index of the most significant bit within a uint 256. So at first it just looks a bit scary, but the AI can easily tell you this is just a binary search in assembly. It has 5 checks because 32 is 2 to the power of 5. And then the assembly, you see the OR, the byte, and AND is just a way to make that more gas efficient. It would give you a list of steps. And this is just a faster way to understand. Of course, you need to have the knowledge to make sure this is right, and you'd also have to check it against the opcode just to make sure all the parameters are right and everything, but it's just a lot faster. Then you can also use it to identify simple vulnerability patterns and improvements. I've seen it and use it to identify incorrect implementation of a documented process. So think of a cryptographic function for which you have a text describing the steps. The AI is pretty good at that. It looks at the implementation, it looks at the steps, and is able to tell you you've missed something, a configuration parameter is wrong, or a step was incorrectly computed. I've seen cases where it was able to tell you a cross-chain message. You send it from source chain to destination chain, and then on the destination chain, there's nothing tying the message sender there to the message sender on the source chain. This is again a pretty simple example. And then things like incorrect order of parameters and gas improvements. Note that it doesn't work well on complex issues that require more understanding of the code base. You have to probably build something on top, either fine-tune the model, but it's unlikely that you're going to fine-tune it better than OpenAI, or try to specialize it again through the context window. So something that was mentioned a lot was the primer documents, where you specify just all the vulnerabilities discovered in ERC 4626 Vault, so the AI is aware of them whenever it gives you answers. Then one other simple example, to write simple tests and proof of concepts. You have a smell in the code, you want to check it quickly. So here again on the Uniswap v4 codebase, I just asked, write me a simple test that creates a pool, adds liquidity, and does a swap. It wrote me this in 30 seconds, and then it was even able to pick up that the Uniswap codebase has all these helpers for deployment and for tests. So the deploy fresh manager and routers is custom code and so on, and it made me a very simple thing, exactly very similar to the Uniswap code base. So just some important last notes. The AI speeds up your process a lot, but you should have the knowledge to validate all the answers and ensure correctness. You're ultimately the decision maker here. Then the AI is a bit like pretty dumb in some ways. It's pretty prone to bias from the auditor. So if you ask it like, are you sure 2 + 2 is not 3? You might actually convince it if you insist a bit. And then try to keep it simple. Don't focus so much on what is the question you're asking, but rather what you're putting in this context window, if it's relevant, and try to fit it there. So try to either compartmentalize the code base into different components and then strip it of less relevant files, such as tests, helper libraries, and view functionality. And then there is also another part, just be safe whenever you use the AI, but this is not a presentation about that. But things like prompt injection and this kind of stuff, whenever you put a code base inside, is gonna act based on what it reads in that code base. But the Red Guild had a good presentation about it yesterday. Yeah, this is everything I had. Thank you very much.
Awesome. Thanks very much for that.